Hey guys, welcome to the Level 3 Calculus 2022 differentiation paper. If you're joining us for the first time, the way this video works is that I go through each question and let you guys know what you need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question, try it out by yourself, and then unpause the video to see how I go about getting my answer. So, without further ado, let's get started. Alright guys, so with question 1a, what we've got is differentiation by chain rule. So what we're going to do is just going to write down this equation here, which is y equals ln of x squared. When I differentiate this, I need to bring the power in the front, so I've got 2 ln of x, and I've got to take away 1 from the power, and of course I've got to multiply by the differentiation of whatever's inside the bracket, and in this case it's actually 1 over x. And so my answer is 2 times ln of x multiplied by 1 over x. Straightforward, what do you call it? Straightforward chain rule question here. Worth and achieved. And we move on to the next question. Sorry, I like this dark green much better than the other one. Cool, so let's go to the question 1b. With 1b, stationary points. Alright, so what we've got to do, we've got to differentiate it, put it equal to 0. And I think the question's only asking for x values. So we're not really looking for the coordinates, but rather just the x values. So differentiate it, put it equal to 0, and you're pretty much good to go. Looking at this one, I mean, I think, it's very easy to tempted to be taking it separate, but I would actually just use the quotient rule for this. So if that's the case, we can actually say f dash of x equals u dash v minus uv dash over v squared. So what I'm going to do is I'm going to put u as x squared plus 1, which means u dash is equal to 2x, and v is equal to x, and v dash is equal to 1. So once that's done, I actually put this into my equations, quotient rule equations. So I've got 2x times v, which happens to be x, minus u, which happens to be x squared plus 1, multiplied by v dash, which is 1, and all of that is divided by v squared, which equals to x squared. So simplifying this, I've got 2x squared minus x squared plus 1 divided by x squared. So that's what I have so far. And remember that we're going to put this equal to 0 to find out what the x values are, because at stationary points the gradient is equal to 0. So we're just going to put that down, f dash of x equals to 0. And I think by this time you kind of just put that in straight away. You don't need to give a reason or anything like that. So we're going to bring it over here. So 0 is equal to 2x squared minus x squared plus 1. Might as well take it out of the brackets. So it's going to be minus x squared minus 1. And of course that's all divided by x squared. Now cross multiplying the x squared. So I've got 0 equals, because of course x squared comes here, and I've got 0 is equal to 2x squared minus x squared is just x squared. So what I've got here is basically 0 equals x squared minus 1, or I could actually say that x squared is equal to positive 1. Of course, taking square root of 1, you are going to get plus or minus 1. A lot of working here for this question, but it is still only worth and achieved for this question. Cool. So let's go to the next question here. I'm just looking at the answer schedule. No, this is definitely an achieved question. All right. So question 1c. No, I did not get old in that short span of time. Just fell asleep doing that last recording. So kind of have to do it again. But anyway, so here we are at question 1C. So what we've got here is we've got a graph, blah, 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 normal to the function. Okay, so I guess the first step is we've got to try and figure out what this point right there is. Now we know the x coordinate for that point is going to be 0. And we actually need to figure out what the y value is. And to do that, I am going to substitute x equals to 0 in this equation here, because then that's going to be y is equal to square root of 0 plus 2, which means y is equal to square root of 2. So this point that I'm looking at is going to be 0 and square root of 2. Now once I get that point, my next step is to actually figure out what the gradient is. So I'm looking for the gradient, that pink line right there. That's going to be my gradient. Once I figure that out, then I could actually go -1 over that to get the gradient of the normal. So in saying that, what I've got to do is if f of x is equal to square root of x plus 2, I'm going to write that as x plus 2 to the power of half. Then I can say that f dash of x, so when I differentiate it, this is going to be half x plus 2 to the power of half minus 1 is -half. And I've also got to multiply by the differentiation of whatever the bracket is. Now in this case it's equal to 1, so I can just leave it like that. Now that's the gradient function. Now I need to know what the gradient is when x equals to 0. So that means I need to figure out what f dash of 0 is. So I'm going to substitute 0 wherever x is. So I'm going to get 0 plus 2 to the power of -half multiplied by 1. That really doesn't matter. So what I've got here is f dash of 0 is equal to 1 over 2 times 0 plus 2 is 2 to the power of -half. So I can bring that to the denominator, and when I bring it to the denominator, I am going to get 1 over 2 times 2 to the power of +half. And of course I'm going to write it something like this. Now you don't need to actually kind of simplify it all the way down to 1 over 2 root 2, but it does help when you're trying to work out the normal. So once I have once I've got this gradient, I now need to actually work out the equation of this particular line, which is the normal. Now I know the gradient is 1 over 2 root 2, which means I got to work out what the gradient of the normal is. I'm going to go with light green here. So this is where I go, I think it's m1 times m2 equals -1. You might remember this from level 2. So what I've got here is 1 over 2 root 2 times the gradient of the normal is equal to -1. And if I cross multiply it, then I'm going to get the gradient of the normal equals -2 root 2. Okay, now I know this question is dragging on a bit because the next step is we need to come up with the equation of the normal, and then we'll put down y equals to 0 to figure out what the x value is. So quite a bit of things to do still. So I'm going to kind of work through here. I'm going to write my equation of the line, which is y minus y1 equals m times x1. Now the gradient of the normal, that's this part right here. The gradient of that green line is -2 root 2. It goes through 0 and square root of 2. That's the point. So 0 and square root of 2, it goes through that. So that's going to be my x1 and y1. So I've got y minus root 2 equals, what have we got here? Gradient is equal to -2 root 2 x minus 0. Looks good. So I've got y minus root 2 equals -2 root 2 x, and then 0 just, well, that kind of just disappears, and we can rewrite this equation for the normal as -2 root 2 x plus square root of 2. Basically the plus square root of 2 is just switching around that minus square root of 2. Okay, now this is the equation of the normal. So what I've got here is the equation of the normal, and what I know though is the point P, its y value is 0, but I actually need to figure out what the x value is. So for that I need to put this equation equal to 0, because that's the equation of the line. 0 is equal to negative 2 root 2. X is what we're trying to figure out, plus root 2. And if I rearrange this, I'm going to get 2 root 2x equals square root of 2, and then x is equal to square root of 2 divided by 2 root 2, which means I can say that x is equal to a half. Now they are asking the coordinates of p, so we can say that p is equal to half 0. Bit of a massively long question for a merit, but where are we getting our grades for achieved correct derivative with evaluated at x equals to 0? So wow, okay, that's a lot of work for achieved right there, but basically you kind of need to get up to here to get an achieved, and for a merit correct solution with correct dy dx except x equals to half y equals 0 can be implied in the working. Okay, so you pretty much need to do all the way down to the bottom, or even up to this part here, to actually get a merit for this question. It's a lot of work for this question, to be honest, but hey, it is what it is. All right, so let's go to the next question. Okay, so with this question, we've got a parametric equation, so we've got to work out dx dt, dy dt, put that together, and then what are we looking for? Find the coordinates on the curve with a tangent to the gradient. Okay, so we put dy dx equals to a half and figure out what x and y is. Cool. So our first step that we're going to do is we're going to work out what dx dt is. So dx dt is equal to positive 3. Then we've got y, which equals to 3t minus ln of 3t minus 1. So we can say that dy dt equals 3 minus 1 over 3t minus 1, and multiplied by the differentiation of the bracket, which in this case is equal to 3. So we can actually say that dy dt equals 3 minus 3t minus 1. Now the thing is, like, if, if we want to put dy dx, we know that dy dx is equal to dy dt times dt dx. And the good thing about this one, well, not the good thing, the bad thing about this one is that dy dt is actually like a number and then a fraction. So putting them together is a really good idea before we get to the dy dx part. So what I'm going to do is I am going to just do this. Give me 1 second. Let's move this right there. And I'm going to kind of work this a little bit more. So what I'm going to do here is I'm going to go dy dt equals 3 multiplied by 3t minus 1. And also I'm going to have the denominator of 3 is equal to 1. Remember that? So we could also multiply the denominator by 3t minus 1. And on this side I've got just 3t minus 1. So I could write this as, well, I could kind of expand it a bit more, can't I? Yeah, I could do that. So I've got 3 times 3t minus 1. And I've got minus 3. All of that is over 3t minus 1. Okay, so with that in mind, I'm just going to expand the brackets. So I've got 9t minus 3 minus 3. Keep working at the bottom there, but let's go up to here. 3t minus 1, and we can actually put that as, kind of went over my limit here, but we're going to put that as 9t minus 6 over 3t minus 1. Okay, so now that we have that, we can actually put this dy dx, and we can say dy dt is 9t minus 6 over 3t minus 1 multiplied by 1 over 3. Because remember, dx dt is 3, and if dx dt is 3, then dt over dx can be said as 1 over 3. So with that in mind, I could actually kind of put things together again. I'm going to get dy dx is equal to 9t minus 6 over 9t minus 3. Looking good so far. Now going back to the original question. The question actually says, find the x and y coordinates if it has a gradient of half. Now if it has a gradient of half, that means dy dx is equal to a half. So that's what we're going to do here. We're going to put down, because dy dt is equal to 9t minus 6 over 9t minus 3. And we're going to figure out when is this equal to half. Because what's that going to give us is it's going to give us a t value. And then once we get the t value, we substitute it in x and y to get the x and y coordinates. So at this point, I'm going to cross multiply. And I've got 2 times 9t minus 6 equals 9t minus 3 times 1. I can just ignore that. So I got 18t minus 12 equals 9t minus 3. Rearranging this, I've got 18t minus 9t equals negative 3 plus 12. I've got 9t equals 9. So t can be said as 1. Now if t is equal to 1, we're going to go right back to the top, where at the original part of the question it says x is equal to 2 plus 3t. And because t is equal to 1, we can say 2 plus 3 times 1. And x is equal to 5. And then we've got y, which we need to do as well. So y is equal to 3t minus ln of 3t minus 1. And because t is equal to 1, we're going to get ln of 3, 1 minus 1. So that's going to be 3 minus ln of 2. And you can actually leave your answers like that. So you can actually say that x is equal to 5 and y is equal to 3 minus ln of 2. Now, grades wise, what do we got? Correct expression for dy dx is going to get you an achieved. So, and the thing is, guys, like, I would, if you're stressed about it, like, you don't need to do the whole divided by 1 and kind of putting together as a single fraction. So I'm actually talking about this point here. So you could have actually gone from there and kind of did dy dx is equal to dy dt times dt over dx. So what you could have done also is you could have just written it like this: 3 minus 3 over 3t minus 1, and that's your dy dt multiplied by 1 over 3. That's like another way to kind of do it, so that you can still at least get an achieved if you feel a little bit lost with kind of putting that whole denominator as one single denominator. As for merit, correct solution with correct dy dx is a merit. So you do need the final answer, which is x and y. So up here is what we're looking at for merit. Cool, let's go to the next question. I'm gonna blow it up a bit. All right, guys, so for this question, what we've got is a proof question, and we've got to try and prove that it doesn't have any points of inflection. So we've got to double differentiate it. That's our starting point. That's our first thing. Once we double differentiate it, then we can actually kind of work around the points of inflection. So our first step is to actually double differentiate it. So what we've got here is we've got f of x, always like working with f of x, is e to the power of px squared, which means f dash of x is going to be differentiation of px squared, which is 2px, multiplied by e of px squared. So nothing really changes there. And then I've got to differentiate it, double differentiate it, and what I've ended up with is a product rule. So 2px is going to be one of those products, and then epx squared is another one of those products. So if I'm using product rule for this, I'm going to put this as u and v. Let's kind of go with the matching. So I can say that u is equal to 2px, which means u dash is equal to 2p, and then v is equal to e of px squared, which means v dash is what we just got before, which is 2px e of px squared. Now, with that in mind, what we can do is we can actually say f double dash of x is equal to u dash v plus uv dash. Now, u dash is equal to 2p, v is equal to e of px squared plus u, which is 2px, multiplied by v dash, which is another 2px, e of px squared. Okay, so at this point I can kind of look at what's my common factors here, and I can kind of see that 2p is a common factor. What else? Let me just go here. So all of this has 2p is a common factor, and I also have e of px squared as a common factor. So I could actually take it out, take out 2p e of px squared, and inside the bracket I'm going to get 1 plus 2px squared, because remember that you've got x1 there, and then you've got another x1 there, so those two things are going to multiply to 2px squared. Okay, so this is our f double dash of 0. Now in terms of grades, I'm just going to kind of mark along as we go along. So correct dy dx gets you an achieved. So this part right here is going to get you an achieved for this question. All right, and correct the second part of it, finding f double dash of x, and if you're correct with it, you are going to actually get a merit. Now we're going to go into the excellence part. That actually says that it proved that it doesn't have any points of inflection. That basically means we want to actually see whether f double dash of x is going to be 0 at some point, because that's what point of inflection is. So we can kind of say at point of inflection, we can say that f double dash of x is equal to 0. So if that's the case, then we can actually say 0 is equal to 2pe px squared multiplied by 1 plus 2px squared. Now treat it like two brackets, and this is very reminiscent of level 1 algebra when you had like those two brackets equal to 0. One of the brackets has to equal to 0. All right, now we're going to try and figure out whether it's possible for any one of these brackets to be actually 0. So what we're going to do is we're going to look at the first bracket here, which is the pink bracket here. All right, now I want to see if this is possible for it to equal to 0. So I'm going to call this equation 1 here for now. Equation 1. So let's have a look at equation 1. So if we look at that, we're going to get 2pe px squared is equal to 0. Now what we can do here is we could actually take out, because it's 0, we can pretty much get rid of the, what do you call it? We can get rid of 2p, because when we take 2p to the other side, it becomes 0. And so we're going to get e of px squared is equal to 0. And then if we take ln of both sides, we're going to end up with px squared is equal to ln of 0. Now here's the first kind of problem. In your calculator, you kind of, I mean, if you've done it, you would know that ln of 0, it doesn't actually work out. All right, so you can't really have this equation equal to 0, because it's actually there's actually no solutions for it. All right, so, and if you think about it in a different way, an exponential curve, and if you look at p is a positive real constant, right? That basically means, I'm gonna try and show you guys this, why it can't actually equal to 0. Let's see if this actually works. Whoa, where did it all go? Graphing calculator. That is massive. What happened here? I've got no idea what happened here. Give us a second. Let's just find out. Settings. I'm gonna pause and be back. That's too tiny, but there we go. That looks much better. Let's move this out here. So our equation that we were working with was 2p e to the power of px squared. So px squared. And what we're going to do is we're going to add a slider, which is a positive value, right? No, of course, it's ex squared. I'm looking at positive value. And as you guys can see, when p is actually a positive number, what's happening is that the graph is actually not touching 0 at all. In fact, it can never equal to 0 unless it is, when it equals 0, well, that's going to equal to 0. But even if I go 0.00001, theoretically that should not be equal to 0. And if I zoom in quite a bit, it would actually work out. But you kind of see what I'm trying to do there. All right. So anything that's if p is a positive number, that graph is never actually going to touch. It's never going to touch y equals to 0. All right. So that's just kind of proving that equation 1 can't actually equal to 0. What we're going to do is we're going to go look at the second equation. Now the second equation, which is 1 plus 2px squared. So this is equation 2. And we kind of need to say that in the first one, equation 1, no solution as ln of 0 doesn't exist. And then we're going to look at the equation 2. 1 plus 2px squared is equal to 0. Now what happens in this case for equation 2 is we're going to end up with 2px squared equals to minus 1. Px squared is equal to negative 1 over 2. And then x squared is equal to negative 1 over 2p. Now the problem is, again, if I take x and if I take a square root of this, I'm actually going to get square root of a negative number. And square root of negative number, again, no real solutions, right? So because you can't actually take square root of a negative number. So we can kind of say that there's no real solutions for this as well. And also, if we have a look at this particular equation, where is it? 1 plus 2px squared. Where is it? Going back to this. So 1 plus 2px squared, because p is a positive number again, and because p is a positive number, what you're going to get is a quadratic equation. And because of that 1, it's always going to be, the vertex is always going to be at 0, 1, regardless of what the p-value is. It's only when it hits that 0, or actually negative 1, that it's actually going to go even, well, actually below, anything below a negative number, it'll eventually hit it. But as you guys can see, if it's positive, it doesn't actually hit the, what do you call it? It doesn't hit y is equal to 0. So pretty much what we've kind of proven is that because of both equations can't actually equal to 0, therefore we can kind of say that if you look at the original question, we've actually just proven that it doesn't have any points of inflection. So we might just write a little statement. Since either equation has no solutions, we can say that equation has original f of x has no points of inflection. It's always good to write a little statement, guys, just so that you kind of can communicate to the marker what it is that you're doing. Sometimes, you know, it's really important that you do that. In terms of grades, T1 is, you kind of need to do the equation 1 and equation 2 for a T1, which is that 7 points, I believe. T2 is E8, isn't it? T2 is E8. And then if you want a full 8 excellence marks for it, here we go, T2, correct proof with correct derivatives. We've done that. Both parts of the equation set to 0, and the reason for there being no real solutions given for both equations. And I think we've done all of that. And if we do all of that, then we pretty much can say that we can actually get an E8 for that question. Cool. That's basically it for this question 1. We go to question 2 next. Alright guys, with question 2a, what we've got is differentiate f of x. So what we've got is a product rule. So kind of recognizing that we've got one product here and the other one is there. And we are going to pretty much write this up. What are we going to do? So u is equal to 5x minus 3. And then u dash is equal to 5. And then we can say that v is equal to sine 4x. V dash is equal to cos 4x, and of course don't forget to multiply the differentiation of the bracket, which is equal to 4. So with that in mind, we can kind of say that f dash of x is equal to u dash v plus uv dash. So we're going to get 5 sine 4x plus u, which happens to be 5x minus 3, multiplied by v dash, which is 4 times cos 4x. And the grade for this question is worth and achieved, guys, and you've got to get the full everything right. And I'll tell you guys this right now, the part where people kind of not get achieved is they tend to forget this little 4 here. All right, like you kind of do the product rule, but then you forget about that little 4x and how you got to differentiate it. So it's just a good little practice, even if it's just like 1x. Get into the habit of writing times 1, because then you'll know, oh yeah, whenever I do like the trig functions, I've got to differentiate whatever's inside the bracket as well. Cool. Next question. Find the gradient of the tangent. Okay, so we're going to differentiate and then put x equals to 2. So what I'm going to do is f of x is equal to 3x squared minus 2 to the power of 3, which means f dash of x is equal to 3 times 3x squared minus 2 to the power of 2. And of course, don't forget, just like I said in the previous question, multiply by the differentiation of whatever's inside the bracket. So in this case, we're going to multiply it with 6x. Now, we're looking for the gradient at 2. So we're just going to substitute 2 wherever x is. Minus 2 squared times 6 times 2. And we're going to get, what do you got, 12. 12 minus 2 is 10. 10 times 2 is 100. So 300 times 6 times 2, which is 12. So 3600. Okay, so that is what our gradient is, 3600. And again, it's actually worth a quick fire achieved. And we move to the next question. It's always funny, we always fly through achieved questions and then we get to like merit and excellence and spend like 20 minutes on them. Anyway, question C, what we've got is object is traveling in a straight line, distance is that. Find the times when the object is stationary. All right, for stationary, we know that the velocity of this object has to equal to 0. So what we want to know is when is v of t equal to 0. So with that in mind, we've got the distance formula, which is, so we've got to differentiate to get the velocity function. So I've actually got to use the quotient rule for this. So I'm going to put down u is equal to t squared minus 6, which means u dash is equal to 2t. Then we've got v, which is in the denominator, which equals to 2t cubed. And v dash is equal to 6t squared. So we can say that velocity, I should have actually used f and g, but it doesn't really matter. I mean, as long as you understand what's happening here, then it's fine. Maybe I might just do this. Hang on, hold on. I might actually go d dash. Remember, this is still the same as v of t, because if you remember, you get dva. You got to differentiate to get to velocity, differentiate to get to acceleration. So I'm just putting d dash of t because after I did it, I realized that I've already got v of t and I put v as part of my quotient rule. So I've got u dash v minus uv dash divided by v squared. So u dash is 2t, v is 2t cubed, minus u, which happens to be t squared minus 6, times v dash, which is 6t squared. All of that is divided by v dash. No, v squared, isn't it? Yeah. 2t cubed to the power of 2. So at this point, I've got to kind of simplify everything and put it equal to 0, because that's literally what the question's actually asking. So in the numerator, I've got 4t to the power of 4 minus, I've got 6t to the power of 4 minus 36t squared divided by 4t to the power of 6. So you got a little bit of manipulation that needs to happen here. 4t to the power of 4 minus 6t to the power of 4 plus 36t squared. All of that is divided by 4t to the power of 6. Okay, still carrying on with this. What have we got? 36t squared minus 2t to the power of 4 over 4t to the power of 6. Now remember that velocity is equal to 0 for stationary, so I can just put this equation equal to 0, and I've got 36t squared minus 2t4 times 4t6. Now the 4t6 goes across to the 0, and that becomes a 0. So I've got 0 is equal to 36t squared minus 2t to the power of 4. I can take out 2t squared as a common factor, which means I'm going to get 18 minus t squared is equal to 0. And if I do 0 divided by 2t squared, that's 0. So I've just got 0 is equal to 18 minus t squared. Alright, so if 18 minus t squared is equal to 0, I can rearrange this and I get t squared is equal to 18 and t is equal to square root of 18. Now obviously I'm going to ignore the plus or minus part, and the reason I'm ignoring plus or minus part is in the original question it actually says t has to be greater than 0. So with that in mind, grades wise, correct derivative is getting you an achieved, which is probably at this stage right here. If you write everything right, like without any kind of mistakes, then your final answer here is actually going to end up with a merit. Okay, next question. What do we got here? Rectangle with one vertex 0, 0. Okay, yep. Find the maximum possible area of the rectangle. Cool. So these types of questions, guys, what you're going to get is, you know, like you just got to work out the area of this rectangle in terms of x. Now, normally, remember that like this is the x part is actually from here to here, and the y part is from here to here. So in other words, we can actually say area of this rectangle is equal to base times height, which is x times y. And that's literally what we're going to do here, because we know that y is equal to this, because that's already given to us. So it actually says y is equal to that, which means we can say x times 6e1 minus 0.5x. And what we've got to do is we've got to differentiate this, put this equal to 0, find out what x is, and then substitute it back into the original equation to actually get our area. So with that in mind, looks like another product rule here, because we've actually got x and then we've got this whole thing on its own, which is going to create a product rule here. So we're going to write down u is equal to x, u dash is equal to 1, v is equal to 6e1 minus 0.5x, v dash is equal to, it's going to equal everything as is, but I've got to multiply by the differentiation of whatever the power is, and in this case it's going to be negative 0.5. Cool. So we can actually write that area, the differentiation of area is equal to u dash v plus uv dash. We're going to get u dash is equal to 1, so we've got 6e1 minus 0.5x plus u is x times v dash, which happens to be negative 0.5 multiplied by 6e1 minus 0.5x. So basically, guys, just to kind of reiterate that, I've put this entire thing, I hope you can see it, which is, no, sorry, hang on, let me just get rid of that last bit, which is this thing right here. All right, and the x happens to be from the yellow part, which is the u equals to x. That's the u part right there, and then v dash happens to be that. So hopefully you guys can see what where that actually came from. All right, sometimes it can be a little bit overwhelming seeing all that exponential things there. Now we know that the area is equal to 0 for maximum area, right? So we're going to put down 0 is equal to 6e1 minus 0.5x plus x times negative 0.5 times 6e1 minus 0.5x. So at this point, what we can kind of say is that we've actually got a common factor of 6e1 minus 0.5x, and inside the bracket we're going to get 1 minus 0.5x. So basically we've got these two things equal to 0. Now if we, like, this is very similar again, like remember we've got these two brackets that equal to 0, and we can actually put down each bracket equal to 0 and find out what's going to actually happen here. Now if I do my first bracket, I've got 6e1 minus 0.5x is equal to 0, then e is equal to 1 minus 0.5x. Now 0 divided by 6 is 0, and here comes the problem. 1 minus 0.5x equals ln of 0, and remember we did this earlier, we can't really have ln of 0 because it doesn't work out. So this doesn't work out, which means our next equation is 1 minus 0.5x is equal to 0. So negative 0.5x equals negative 1, and x is equal to negative 1 divided by negative 0.5. So x is equal to 2. So if you go back to the original question, now it actually says, let's go back here. Sorry guys, I know I kind of rushed through it. It says find the maximum area. Now we know the maximum area happens when x is equal to 2, and because of that we can actually say area is equal to, where's that equation, x times 6e1 minus 0.5x. So area is equal to 2 times 6e1 minus 0.5 times 2. So we're going to get area is equal to 12 times e to the power of 1 minus 1 is 0, e to the power of 0 is equal to 1. So our maximum area is actually equal to 12. So correct derivative gets you an achieved. So that would be right here is where we're looking for achieved. And for merit is correct solution with correct derivative. So that's this part right here is actually going to get you a merit. So it's not a, you know, I mean, like I've seen these questions pop up in level 1, not level 1, level 2, and it's pretty much the same idea, guys. You know, just got to go back to that, write the equation down first for the area of whatever shape you're trying to figure out, and then just replace the y with the equation, and you're pretty much good to go. It's a bit of a standard question that comes all the time. Well, not all the time, but it, you know, if you do see it, then you know what to do. Cool. So let's go to the next question. Pause and have a read through this. All right, so with this question, what we've got is we've got a gradient of 1 at point P. So that right there is a gradient of 1. Something like that, right? That's what it looks like. This tangent intersects the x-axis and y-axis at point R and S. So intersects the x-axis at R. So we can say that this point is R, this point is S, and then prove that the length of RS is 7 root 2. Oh, geez, looks like you've got to do, it's not too bad. I mean, differentiate, put the gradient, put it equal to 1, get the equation of the pink line, and then get the points R and S, and then calculate the distance between those 2 points. So it's actually not a bad excellence question, but let's get going anyway. All right, so the first thing we want to do is we're going to differentiate the equation here, but before I do that, I'm going to actually get rid of the squared. So I'm going to end up with y minus 5 is equal to 16 x minus 2 to the power of half. And because it's to the power of half, I can say y minus 5, 16 to the power of half is 4. And here I've got x minus 2 to the power of half. Then I can say y is equal to 4, x minus 2 to the power of half plus 5. Cool. So this is pretty much my equation. Now, some of you might sit there thinking, oh, can I actually use implicit differentiation? Now, if you're comfortable doing implicit differentiation for this, by all means, go for it. If you don't know how to do it, then this is probably the method you could go with as well. Now, either way you do it, you're still going to end up with dy dx, which you need to prove, put it equal to 1 to kind of work it out. So we're going to actually work out what dy dx is. So I'm going to differentiate this, which means I'm going to get 4 times a half x minus 2 to the power of negative half. Plus 5 becomes a 0, so don't really have to worry about it. And what I've got here is dy dx is equal to 4 divided by 4 times a half is 2. And I'm going to bring that x minus 2 to the denominator, which is, I could rewrite this as 2 to the power of square root of x minus 2. It wouldn't really matter, but that's my formula for dy dx. All right, now that's my gradient function. So I need to figure out what the point P is. Now, and I know that the gradient is equal to 1. So I could actually say dy dx is equal to 1. So I'm going to put down 1 is equal to 2 root of x minus 2, cross multiply, and I'm going to get x minus 2 square root of that is equal to 2. Square both sides, I'm going to get x minus 2 is equal to 2 squared. X minus 2 equals to 4, and x is equal to 6. Now this particular 6 here is that right there, the x coordinate of P. That's what the 6 is. Now if that's the case, I could actually figure out what y is, and I'm going to kind of carry on here. So y is equal to 4 times x minus 2 to the power of half plus 5. And I know that x is equal to 6, so I've got 6 minus 2 to the power of half plus 5. So y is equal to 4 times 4 to the power of half plus 5. Y is equal to 4 times 2 plus 5. Y is equal to 13. So what I've got here is P is actually equal to 6 and 13. So now that I have the pink line's gradient, which equals to 1, and I also have the pink line's point that it goes through, which happens to be 6 and 13, I could actually work out the equation of this line. And if you remember, we did this earlier at 1b, when we did, not 1b, 1c. We kind of did a similar question like this and had to put down x equals to 0 and y is equal to 0. So that's pretty much what we're going to do. But before we do that, we need the equation of the pink line. We know the gradient, which is 1. We also know the point it's going through, which is P, which happens to be 6 and 13. So I'm going to write an equation for this. And what we have here is y minus 13 equals 1 times x minus 6. Y minus 13 is equal to x minus 6. Y is equal to x minus 6 plus 13. Y is equal to x plus 7. So pretty much what I've got here is equation of the pink line, which happens to be y is equal to x plus 7. Now what I do know is at point S, x is equal to 0, and I need to figure out what the y value is. So when x is equal to 0, y is equal to the equation of the pink line is x plus 7. So y is equal to 0 plus 7, y is equal to 7. So the point S happens to be at 0, 7. Now if I look at point R, I know the y value is 0, but I don't know what the x value is. So in that case, I'm going to put down y is equal to 0, and then I've got y equals x plus 7. So 0 is equal to x plus 7, and I can say that x is equal to minus 7. So point R is equal to negative 7 and 0. Now we got the 2 points, we can actually work out what the distance between the 2 points is. Now if you've forgotten, you're like, I can't remember the equation for the distance between 2 points. Remember, this is just Pythagoras, and that's distance between 2 points is just Pythagoras. So if I actually take this little triangle out here, I'm talking about this yellow triangle, right? I'm going to take it out here. Coordinates wise, I know that this is negative 7, 0, and then this point here is 0, 7. And I also know that this point here is the origin, which is 0, 0. So if you think about it in the distance between the bases, it's 7, right? So that's like positive 7. because I'm looking at the distance. I'm not looking at the -7 part of it. I'm looking at it like the actual distance. And this is also 7 because it's actually going up by 7. So the base of the triangle is 7 and the height of the triangle is 7. Now I need to work out what the hypotenuse is. So if I actually work out the hypotenuse, that's going to give me the distance between 2 points. So I'm going to put this as h. So h squared is equal to a squared plus b squared. H squared is equal to 7 squared plus 7 squared. H squared is equal to, what do I got here? 49 and 49, which is 98. But I could do it like this though. Actually, no, I'm going to do it like this. 98. Then I can say that h squared is equal to 49 times 2. H is equal to square root of 49 times 2. H is equal to square root of 49 square root of 2, which means h is equal to 7 square root of 2. And I believe that is what the question said there. Sorry, I kind of like blow it up a little, but prove that the length of RS is 7 root 2, and I think that's what we've just done here. I might just put these points here, which is R and S. Therefore, we can say that distance of RS is equal to 7 square root of 2. Now you can actually do it with your distance formula if you want to. That is absolutely fine. But like I said, I mean, like if you can't remember the distance formula, just remember that it's just Pythagoras, and you just got to get the whole units of the base and the height, and you're good to go. It's actually a nice, excellence question. I'm not gonna lie, because it's like it's a lot of work, but it's doable, and that's always nice. So dy dx is gonna get you an achieved, which is somewhere here. That part there is gonna get you an achieved. Merit is correct x and y values found 6 and 13 with correct dy dx. So that's actually finding p. So I guess somewhere here is getting a merit where you get 6 and 13. And I think if you do everything correct solution with correct dy dx, you actually get a T2, which ends up being 8 points. Finds the equation of tangent and both x intersects with correct dy. And if you get up to this part here, you actually end up with E7. So you actually end up with getting 7 points for that question. So yeah, that's the distance formula. It's going to give you that 1 extra point to get that full 8 points for this question. Anyway, guys, that's basically it for question 2. We move to question 3 next. All right, so question 3, what we've got is, you do something crazy like question 2E, like an excellence question, and then you jump to these achieved questions, and you almost feel like, wow, that it takes longer for me to talk this than to actually do this question. What we've got here, y is equal to e to the power of 4x to the power of half. So we can say that y dash is equal to e to the power of 4 times x to the power of half multiplied by the differentiation of 4x squared, which happens to be, what do we got? We have to write down everything, isn't it? So we got 4 times a half times x to the power of half minus 1, which happens to be x to the power of negative half. And you can pretty much leave your answer like that. As long as you have all the times in there, this is going to be worth and achieved. All right, let's go to the next question. My favorite type of question. Unfortunately, these questions have actually been converted to achieved questions. They used to be merit, and I think they got onto us fairly quickly that if you answer this question, you end up with merit, which is like 5 points. Then you get one more differentiation question correct, and you get like 2 points. And guess what? You've passed level 3 differentiation by answering 2 questions. So I guess that's why they kind of moved it to achieved. But anyway, let's have a look at this. First part is find the values of x where f of x is not differentiable. Now guys, if you're not sure about these types of questions, I have like a tutorial stuck in the calculus differentiation tutorial, live tutorials. I think it's in 2016 or 17, might be 17. It's a pretty much a 1-hour tutorial covering all these types of questions with different things. Someone remind me to link it. I'll probably most likely forget. But anyway, let's go through this. Find the values of x where x is not differentiable. All right, so we've actually got 3 points there where things can't be differentiated. Number 1 is there. Number 2 is any sharp points. You can't actually differentiate it at sharp points. So we've got -4, -1, and +1. Next is we're looking at is find the values for f of x, f dash of x is greater than 0. So we want to know where are all the gradients, not greater than 0, equal to 0. So it means we're pretty much looking for flat lines, right? So that's pretty much what this means. We've got our first kind of flat line right there, which happens to be at -3. And then our second flat line is pretty much starting from here. We can't actually say it's at 1, but we can actually say that when x is greater than 1. Because at 1, you can't actually differentiate it. So therefore, we can't actually put x is greater than or equal to 1. The last one is what is the value of x tends to -4, which is this one here. X tends to -4. You can kind of have a look here. It is, and because both the graph, I'll try and do this. Is it like this? Yeah, like this. So what you got is like they're both heading towards +3. So that is pretty much going to be our limit for x tends to as x gets closer to -4. Cool. So that's pretty much it for this question. You need 2 correct parts of this question, of question 3b. Of 3b. I don't get that part. I guess you kind of need to get like 2 of those parts correct to get an achieved. So as I said, this is still just an achieved question. Yeah, 2 parts correct for an achieved. All right, let's go to this one here. The classic rate of change question. I always, you know, whenever I see rate of change questions, like I don't even read like any of the kind of things, right? I kind of just look at the what's been given and what I can actually work. Now the first thing I'm going to do is like I'm going to go look for my constant, like see in this case they've got constant rate of 20 centimeter cubed by seconds. So straight away, this is what I do. I know that the volume is going to be in centimeter cubed, right? That's kind of like the first thing. My second thing is looking at this here. This is seconds, so that's actually time. So what I'm going to write down here is dv dt is equal to 20. That's like my first thing that I do. The second thing that I do is I look at the formula that they've given me. Now in this particular formula, what I actually have got here is I've got volume and I've got my next variable, which happens to be h. So I know that if I differentiate this particular equation, I'm actually going to end up with dv dh. Now this is just like without even reading the question, right? Just trying to extract whatever information I have in here. And the last thing is like if I read the question, it goes, oh, find the rate in centimeters per second. Okay, so if I go here, my time was in pink, so that's in t. Centimeters, now obviously that's not volume. Centimeters in this case, I'm looking at the height because it actually says that. So I'm actually looking for dh dt when the height is 3. So dh dt, what is dh dt when h is equal to 3? So this is pretty much how I extract the information from these types of rate of change questions. Like if I ever see find the rate, do this, do that, I'm like, okay, where's my constant? What's the formula? What am I looking for? Because here's how this whole thing works out beautifully. Because I can write down dh dt is equal to dv dt multiplied by dh dv. And because I've got dv dt, which is this thing here, and I've also got dh dv, which is basically this thing, but just flipped upside down. So my first step is to work out what dv dh is. So I've got pi times 3/2h squared plus pi times 3h. I've just expanded that pi out into the bracket just to make it easy for me. Then I can do dv dh, which is equal to 3 pi, the squared and the d disappears, plus h goes away, which is 3 pi. So dv dh is equal to 3 pi. No, not 3 pi. Hang on, something's not right here. Let me just check. No, it looks right, looks right. So we're going to take our pi, 3h plus 3. I mean, I don't know why. We could have taken the 3 out as well. It doesn't really matter. So that's my dv dh. And what else do I have? No, that's it. So dh dv, I just flip it over. dh dv would be 1 over pi times 3h plus 3. So if I go back to my rate of change question, I've got dv dt, which is 20, multiplied by dh dv, which is 1 over 3h plus 3 times pi. Now it actually says that h is equal to 3. So because h is equal to 3, then I can say, kind of need to write this separately, 20 times 1 over pi times 3 plus 3, and I'm going to get 20 over 12 pi. Can I leave it like this? Probably can't, because I probably could. I would just put down that dh dt is equal to 20 over 12 pi centimeters per second. Now in the some people like, see, this is what they've done in the answer schedule, right? Like, so they've actually put down 20 over 12 pi, and then they've just put it equals to 5 over 3 pi and then 0.531. Would I leave my answer as 20 over 12 pi? I don't see why not, but like, look, if you're worried about it, just chuck it in the calculator and put it as a decimal answer. But 20 over 12 pi is a lot more accurate. I mean, yeah, you could simplify it to 5 over 3 pi if you want to. Anyway, correct expressions for dvh and dv dt gets you an achieved, which is basically this part and also recognizing this part here. And final part is going to be worth the merit. All right, so next question. So with this question, what we've got is we've got to work out the stationary points, and we've got to determine the nature. God, we've got to double differentiate this equation as well. All right, so let's start doing f of x first. So f of x is equal to 9x minus 2 plus 3 times 3x minus 1 to the power of negative 1, which means f dash of x equals 9 plus 3 times negative 1 times 3x minus 1 to the power of negative 2 multiplied by the differentiation of whatever's inside the bracket, which in this case is 3. So we've got f dash of x equals 9 minus 9 3x minus 1 to the power of negative 2. So we know that at stationary point f dash of x equals to 0. So we can put that f dash of x equal to 0. I'm just going to put that little statement there for stationary points. So 0 is equal to 9 minus 9. Now that 3x minus 1 to the power of 2. I'm just going to bring it down to the denominator because it's just easier, because then I can rearrange this as 9 over 3x minus 1 squared equals 9. Cross multiply, or actually I might actually just do this. 9 divided by 9 equals 3x minus 1 squared. Just trying to be a bit cheeky there. How much space have I got here? Got a bit of space, that's good. So then 3x minus 1 squared is equal to 1. 3x minus 1 is equal to square root of 1, can be written as plus or minus 1. So 3x is equal to 1 plus or minus 1. And finally, I can say that x is equal to 1 plus or minus 1 over 3. So, what have I got here? I can say that x is equal to 0 or 2 over 3. Because 1 minus 1 is 0. 0 over 3 is just 0. And then 1 plus 1 is 2. And then 2 over 3. Well, those are my two values, right? I got x equals to 0 or x equals to 2/3. Now, this is where these stationary points are, but I need to figure out which one has the maximum and determine its nature, because I got to figure out which one is the max and which one is a minimum. Now, to do that, I need to differentiate it twice. So I've got f dash of x equals 9 minus 9, 3x minus 1 to the power of negative 2. That's where it is. So f double dash of x, 0 minus 9 times negative 2 times 3x minus 1, negative 3, multiplied by the differentiation of the bracket, which is 3. So f double dash of x is 9 times 2 times 3 is 54. And the 3x minus 1 to the power of 3 gets in the denominator. So this is pretty much my equation for f double dash of x. And I need to put down f double dash of 0 first. So I got 54 over 3 times 0 is 0 minus 1 cubed, which means I'm going to get 54 divided by negative 1 cubed, which is equal to negative 54. And because f double dash of 0 is less than 0, I can say that this is a max. And then f double dash of 2/3 equals 54 divided by 3 times 2/3 minus 1 cubed. I'm going to get 54 over, what do I got? 1 cubed, isn't it? 54 over 1 cubed. Because 2 minus 1 is 1, 1 cubed, that's going to equal to 54. And because f double dash of 2/3 is greater than 0, we can say that this is equal to minimum. So pretty much what we're going to say is max when x equals to 0 and minimum when x equals to 2/3. So grades wise, guys, no, wow, this is an excellence question. What do you know? I was surprised by that, to see this as an excellence question, but there you go, look at that. T1 correct solution with correct derivative, nature of each point, turning point determined with first or second derivative test is an excellence question. So that gives you an E7. So it could end up with 7 points for that. Correct solution, correct derivative is worth an achieved. So that is somewhere here. A merit is nature of each turning point theta, but not, okay. Correct solution with correct derivative. Correct solution with correct derivative. So it could be somewhere here, but you still got to mention your nature of the points to get the full full merit. So you can kind of still, you can probably graph that and kind of visually look at where the maximum and minimum is and kind of state that. That's one way of doing it. So I'm guessing that's what they're thinking about when they're saying, like, I'll show you guys the answers. So if you look at this part here, the nature of each turning point stated but not determined. So you're like guessing and checking almost, or putting in the graphics calculator and figuring out which one is a local max and minimum. Yeah, not bad for an E7 question, but anyway, let's go to the last question here. I'm looking at this question, I'm like kind of giggling away here. Like the truth is, I've actually seen this type of question before, and I think I don't know, maybe 2013, 14, I saw a very similar question like this. Because I remember with my 2017 class, I actually did this as an experiment within my class, or a similar type of question, right, like this. And I think lately I actually even saw like a TikTok video on it, but it's just cool, kind of crazy to see this type of question pop up in the exam. But anyway, look, let's get going. So when this person, who is Megan, so H to P, whatever that distance is, she can travel this distance. So along this line here, it's going to be 10 k's per hour, right? And then at the top, when she goes along the pathway, she's going to be going at 6 kilometers per hour. Now, the thing is, it's an optimization question. So we're trying to figure out what's the best point at P so you can actually keep the limited, so it takes the least amount of time. So if you think about it like this, the first way we've got to set this whole question up is like this. Whatever HP is, the distance from H to P, whatever that distance is, that she's going to travel at a speed of 10k. All right, so HP divided by 10, whatever that distance is, if you divide it by 10, it's going to give you the time. Plus, we've got PS, and that's going to be divided by 6. And that's going to give you the time that she's actually taking to go across the park. That's from PS, because of the speed is 6, right? So just to kind of highlight the points. So that is PS right there. And then we've got HP, which is here. So you can kind of see that the total time, if I put the time that she takes, is going to be HP over 10 plus PS over 6. Now, the problem is we don't know what that optimal distance is. Now, there is one other thing I'm going to do here. What I'm going to do is I am going to put down this point right here from P to Q. And I'm going to call this X. So the first step for you guys is to understand is that if PQ is equal to X, then HP is going to equal 4 minus X, because the entire distance from H to Q is 4. And so this part, H to P, is going to be 4 minus X. Next is actually coming up with an equation for the green line, which is PS. Now, what we've got here is we've actually got a right angle triangle, which means the green line is actually the hypotenuse. All right, so if that's the case, then we could actually say H squared is equal to A squared plus B squared. H squared is equal to X squared plus 2 squared, and then H is equal to square root of X squared plus 2 squared. Or in other words, we can say square root of X squared plus 4. This is what the green part is actually worth. And the 4 minus X is actually the yellow part. And I think this is probably the most trickiest part of this question. And I think once you get this part of the question, the rest of it is just substituting and differentiating and solving. So we've actually got the formula for total time now. Our total time could be said that HP over 10. Now we know that HP is equal to 4 minus X. That's over 10. Plus PS, which happens to be square root of X squared plus 4. And that she's traveling at 6. And guys, we're pretty much got the equation. Now we just need to differentiate and put it equal to 0 and find out what X is. So in saying that, we're going to do our first step, which is get rid of the square root function. And we're going to write that as to the power of half. So T dash, or T of X, if you want to call it that, T dash is equal to, I'm going to separate this actually before I do that. Hang on. So T is equal to 4 over 10 minus X over 10 plus X squared plus 4 to the power of half over 6. So T dash is equal to 0 minus 1 over 10 plus a half times X squared plus 4 to the power of negative half over 6 multiplied by the differentiation of whatever's inside the bracket, which happens to be 2x. So simplifying this, we're going to get T dash is equal to negative 1 over 10 plus the 2's cancel out. We've got X in the numerator. 6 stays in the denominator. And then we've got X squared plus 4 to the power of positive half. I moved it to the denominator to make it positive half. Now we know that t dash is equal to 0, that's when your minimum traveling time happens. So I'm going to put that t dash is equal to 0 for minimum. So 0 is equal to negative 1 over 10 plus x 6x squared plus 4 to the power of half. Kind of going to go over here. So I can take 1 over 10 to the other side, it becomes positive. And I've got x 6x squared plus 4 to the power of half. Now unfortunately guys, there's no other way to do this apart from cross multiplying, which means we're going to get, I could actually take the 6, yeah, I'm going to take the 6 across. X squared plus 4 to the power of half times 1 is equal to 1, and then 10 times x is just 10x. Actually I should have left the 6 there, but that's fine. X squared plus 4 to the power of half equals 10x over 6. Now I'm going to square both sides to get rid of that half, and I'm going to end up with x squared plus 4 is equal to 100x squared over 36. Cross multiply this, and I've got 36 x squared plus 4 is equal to 100x squared. 36x squared, 72, 144 equals 100x squared. 144 equals 100x squared minus 36x squared. 144 equals 64x squared. And then x squared is equal to 144 divided by 64. Happens to be some nice numbers here, so we could theoretically write this as 1.5, but like let me just see this. All right, now I know that x squared can then be done, well actually not, like let's do it in the calculator. I mean, I know I could just do it straight up, but it's all right. Exit 144 divided by 64 is equal to 2.25. X squared is equal to 2.25. So x is equal to square root of that. 1.5. Now you might be going, well, what about plus or minus 1.5? Remember, x has to be a positive value. Because of that, well, it can't be a negative value, because remember we said that x is that little part there, and it can't really be a negative value. Okay. So we've got x is equal to 1.5, and I think the question is actually asking from what distance from her home should she choose to cut across the path. From the home, 4 minus x. So if you actually go 4 minus 1.5 is equal to 2.5 kilometers. So you kind of write a statement that she should, well, can't even spell should. She should travel 2.5 k's and then cut across the path. Now it's starting to make sense why this question is only, I guess you could get T1, it actually gives you E8 for this question. But anyway, grades wise, let's have a look. There's no cheat for this. What a surprise. Correct dt dx is worth a merit, which is here. We are looking at a merit. X equals to 1.5 found with correct derivative is E7, or a T1 in this case. I mean, if you get like both of those T1s, you get a, I think you'd get a T2, isn't it? Or how does it work? T2 or 2 of T1. I'm just having a look at this. So you could actually get 2 of T1. So you could, for this question, you could get like the 1.5, and then you could get the T1 from the previous question, which will actually give you T2, which gives you 8 points. Or if you just get the full correct answer for this question, where you say she should travel 2.5 and then cut across, you end up getting that full E8, which happens to be the 8 points right there. In terms of this paper, and I know I've not been doing this before, but like as you guys can see, Achieved with excellence is 20 points. You know, if you get like 3 E7s, you're pretty much looking at an excellence for it. That's pretty decent. I mean, like, it's a couple of easy questions there for excellence anyway. So overall, I think it was not a bad paper. Yeah, even this excellence question here wasn't too bad. Like, this was the find the distance between them. Like, you know, even if you got up to the E7 part, that's like 14 points right there, and then a couple of merits from the previous question 1, and it's fairly easy to get an excellence in this paper. At least that's what I think it is. But anyway, guys, look, if you have any comments or questions, pop it in the comment section below. Yeah, that's pretty much it. I always say this, you know, for differentiation paper, don't leave anything empty. Try and answer as many, like, just differentiate, you know. That's what I'd say to people, and like most of the time you can actually kind of get some achieved points out of that. And also, what I keep saying, somebody remind me to put that tutorial for those limit questions, because that's like an easy achieved questions that you can get as well. Cool. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.